Okay, that was a long question. So that was 7. I think we can probably do one more here. This is probably 8 here. Let's probably do question 8. It says, which salts will be more soluble in acidic solution than pure water? Explain why each salt is not more soluble in acidic than in pure water. All right. So let me write this down first. We have CuCl, CsClO4, CaSO4, BeOH2, and AlPO4. So we have copper chloride here. This is copper 1 chloride. We have this is cesium perchlorate. We have calcium sulfate. We have here beryllium hydroxide. This is aluminum phosphate. And the question is asking us, which salts will be more soluble in an acidic solution than in pure water, right? So when we're talking about solubility, actually, I'm gonna actually, for the sake of time, what I'm gonna do is I'm gonna actually look at the answer, just verify it without, and kind of teach you the concept of this actually, just because it's our last question of the day here, and I kind of want to finish on time. So it says which will be more soluble in acidic solution than pure water. So we're comparing here. Let me do this in blue. We're comparing water and acidic solution. This is water versus acidic solution. So it says here, the solubility of a substance is defined as the amount of substance that's dissolved in a particular volume of solvent. That's good. So we have the association of copper chloride and cesium chloride are as follows. That's good. So they just broke them down into their ions, right? So we have copper and the chloride ion. That's good. We have cesium and the perchlorate ion, which is good. Calcium, we have obviously the calcium and the sulfate ion. We have beryllium and the hydroxide ion, and aluminum and the phosphate ion, right? So they kind of drew, they have all these ones here. And it says in this reaction, chloride and the chlorate ions are passive, that are not readily soluble in hydronium ions. Thus, they are insoluble in acid solution. So what we have when we're talking about this this kind of topic here, it says chloride and chlorate anions are passive. So it says here Cl minus and ClO4 minus are not soluble in acidic solution. So let me draw that. Let me write down what that means. So we only care about basically the anions, right? So we have Cl minus and we have ClO4 minus as well. And basically what it's saying is we're going to kind of we have acidic solution. So we have you can think of it as H3O plus, right? Because it says they're not readily soluble in hydronium ions. So this here would be, you can think of it as H3O plus and H3O plus here. And they're passive and are not as readily soluble in hydronium ions. So thus they are not soluble in acidic solution. So what we have, if we were to basically write a reaction, we would get HCl and H2O, and for this one we would get perchloric acid, HClO4, and we would get some sort of what we have water actually. But if we don't have H3O plus, for example, if we had actually an acid, so let's think of an acid, let's say H2SO4 for both of these guys here, would this actually give us a reaction? In this case, we'd actually have to look at our anions here. We have Cl and we have SO4, ClO4 and SO4, right? So what we have here is that would this actually displace SO4 for us to kind of break down our to make it soluble? In this case, it wouldn't, right? Because we have Cl here versus sulfate here. Sulfate is a much bigger ion, and Cl isn't, right? So this can't kind of like displace it, right? You can think of it in terms of electronegativity, sulfate and chlorine. Same with you can think of it as activity series as well, versus perchlorate versus sulfate as well. So these guys wouldn't actually be insoluble. So this here would actually not give us a reaction here. There'd be no reaction here. So therefore, these are not soluble. And then finally, for these three guys here, we have calcium and sulfate, which is good. They just wrote the dissociation. Beryllium and hydroxide, that's good. Aluminum and phosphate, and these guys are more soluble in our acidic solution, right? Because if I were to write it down, calcium sulfate and H2SO4, for example, sulfate would actually displace chlorine. So for example, if my acid here was HCl plus CaSO4, I would actually get calcium chloride plus I would have H2SO4, right? I would get sulfuric acid. So in this case, it would actually dissolve. If I were to dissolve beryllium hydroxide, HCl plus BeOH2, this one would actually be a neutralization reaction, right? You have a base and an acid, right? So this here would become BeCl2 plus H2O. So this is a neutralization, which will definitely be soluble. And finally, I have aluminum, so HCl plus AlPO4. In this case, I would make H3PO4, so phosphoric acid, and I would also make aluminum trichloride, right? Aluminum chloride here, not trichloride, sorry, aluminum chloride here, right? So this here would be our solution here. These three would be soluble, whereas copper chloride, chloride, and cesium perchlorate would not be as soluble. So this here is my answer. This here is a great solution, good solution, and step-by-step analysis. I liked how they wrote the dissociation reactions for all compounds. So these guys are good, which means solution here is correct. Solution here is correct, and that will be my final answer for that's my final question for today. Again, we're running out of time, so I'll probably save this question for next time. Next time I'm going to do another grade 11 session. Again, if you were in the chat, thank you so much for watching. You can definitely tune into OneClass, and you can tune into my teaching. I stream from Monday to Friday. Monday, Wednesday, Fridays are my math sessions, and Tuesdays and Thursdays are my chemistry sessions. Again, thank you so much for watching. I'm going to stream again in about an hour. We're going to head into some grade 12 material for grade 12 chemistry, and I'll probably do a couple questions from kind of that course as well. If not, I thank you for watching again. Stay safe, stay healthy, and have a great day.